Good morning. This is Tanmay Chaudhary, a second year BTech student from Vellore Institute of Technology, Vellore. Today I'll be talking about Unicast routing protocol as part of my theory DA of network and communication. So, unicast routing is basically the process of forwarding unicasted traffic from a source to a destination on an internetwork. Unicasted traffic is basically designed for a unique address. So we can say that unicast routing is a point-to-point communication arrangement that only occurs between the sender and the receiver. In simple words, it is from one source to one destination. That is one-to-one communication. So what exactly happens in a unicast routing is the traffic is sent from one host to another, then a replica of each packet in the data stream goes to every host that requests it. Then the implementation of unicast applications is a bit easier, I would say, as they use well established internet protocols. However, they are particularly incompetent when there is a need for many to many communication. Unicast uses IP provision techniques such as TCP, that is Transmission Control Protocol, and UDP, that is User Datagram Protocol, which are session based protocols. So once a Windows Media Player client connects via Unicast to a Windows Media server, that client gets a straight connection to the server. Every unicast client that connects to the server takes up extra bandwidth. For instance, if you have 10 clients all performing at 100 kbps streams, it means those clients taking up 1000 kbps. But when you have a single client using the 100 kbps stream, then only 100 kbps is being used. So today I'll be implementing TCP, which is the most commonly used unicast protocol. So transmission control protocol is basically a connection oriented protocol that relies on acknowledgement from the receiver side. So today we'll be designing a chat application using the transmission control protocol. So the code for TCP server or the server side is as follows. So here we are including a bunch of header files and then the required header files, and then we are defining a constant called max with the value 80. Then we are defining a constant called port with the value 8080. We are defining these as constants because they need to stay fixed, like their values cannot vary through the execution of the program. And then there's a function designed for conversation between a client and a server. The function name is func and the parameter is sockfd, which is integer data type, and then we are creating a character array of length max, that is 80. Then we are declaring an integer n, and then we are defining an infinite loop for the chat. This infinite loop is for the purpose of continuous conversation between a client and a server as long as they want. There is no limit, there is no time limit. Then this read, like we are calling the read function to read the message from the client and then copying it in a buffer. So this is the code for that. And then we are printing the buffer which contains the client's messages. So this is printf message from client, like whatever the client has sent that will appear here, and then message to client, like whatever the server has sent that will appear here. So then we are copying the server message in a buffer by using the while loop, and then we are sending that buffer to the client so that the client receives the message from the server. And then if the message contains exit, like if the server side types exit, then the server and the client must exit and the conversation ends. So this is the condition for that. And we print the required message, that is server exit, and then we break out of the loop, of the infinite loop. Then this is the driver function or the main function, where we are declaring all the required variables, and we are creating the socket and verifying it, like using if else. If sock fd is -1, then socket creation has failed and we exit out of the program, and else the socket has successfully been created. And once the socket is created, we assign IP address and port, and then we bind the newly created socket to the given IP address, and then we verify it using if else again. So if it is not equal to 0, then we print socket bind has failed and we exit out of the program, else we print socket successfully binded. So now once the server and the client are ready for the conversation, so the server is ready to listen what the client has to say. In order to verify that, we are giving condition: if listen sock fd comma 5 not equal to 0, then we print listen failed and we exit out of the program, else we print the required message, that is server listening. And then we accept the data packet from the client, and we again verify it using if statement, if else statement. So if it is verified, then we print server accept the client, and then the conversation starts. So this is the function for chatting between the client and the server. So after the conversation is done, we close the socket, so close sock fd. So this is all about the socket part, the TCP server side part. Now we have the client program. This is almost similar to that of the server code. We again include a bunch of header files. We declare the constants, max, port, and the structure. Then we create a character array to store the message of the client, and we create an infinite loop, and this while loop is for storing the message from the client and then sending it to the server through the buffer. And then we print the message from message from server, whatever the message is there in the buffer. And then this is the driver function, where we declare all the required variables, and we create the socket, verify it, and then we again assign IP address and port. We connect the client socket to the server socket and verify it, like if connect sock fd comma all of these structure and all. So this is for verification part. If it is not verified, then we print connection with the server has failed and we exit out of the program, else we print connected to the server, and this is a function for chatting. So once the conversation is done, we close the socket, and these are the output. So as you can see, these are the two terminals. One is for the server side and another is for the client side. Let's run the two programs. First I'll be running the server one. So gcc tcp tcp server dot c server. Okay, just a second, it takes a little time. We'll run our TCP server program. Yeah, so as you can see, it shows socket successfully created, socket successfully binded, and server is listening. This means our socket creation and verification and binding are successful, like there's no failure, and the server is also listening. So now we will run the client program. Client.c TCP client. Okay, so we'll run TCP client program now. Yeah, so this says socket successfully created, it is connected to the server. So now we have to enter a message. So we'll be giving out a client message. As you can see in the server side, it is saying server accept the client. This means the connection between the server and the client is successful. Now we will start our chatting. So I say hi and press enter. So as you can see in the server side, message from client, hi, it has come. Now message to client, so I would say hello, press enter. And as you can see in the client terminal, message from server is hello, enter the message. So the conversation continues as long as the server doesn't press exit or doesn't type exit. So we'll continue this conversation a little more. How are you? Message from client is how are you? Message to client is I'm fine. What about you? So in client also we'll see same here. So now message to client, in this message we will type exit and press enter. Okay, so when we type exit and press enter, the server exits, and you can see in the client window also the message from server is exit, so client also exit. So both the program exits and we get back to our normal thing, like we come out of the program execution. So this was all about the TCP chat implementation. Like this is a kind of chat application that I tried to implement in order to show the working of unicast routing, like the one-to-one conversation between the server and the client.